this as any other means of doing like cheating. You could also, before ChatGPT, you could go to your friend and say, could you please write this for me? And so on. So, the bottom line is, you could think of this as one more efficient way of doing the kind of old way cheating, which is not allowed. And of course, we have to trust also our students to some point. So we say for doing, let's say, a thesis, that certain things are allowed to do, which are allowed in normal circumstances. I can come to you if I do a thesis and ask, what is an AI agent? And you explain to me. Okay, so you can like look up like things like that, but not so that I come to you and say, please write the whole thesis for me. So maybe that's a kind of explanation of how we're thinking of it, that it is like similar to other ways of cheating.
Right.
Yeah.
All right, but what's happening in FKI?
Yes, so the Finnish Center for Artificial Intelligence, which I also represent, is a Research Council of Finland funded flagship in AI. We have been going on already since 1999, so we have been doing quite a long story here already, but we have a series of events. So here you see some of what's coming up. I'm not going to use a lot of time because we have so interesting talks coming up. Then I just wanted also to mention that we are involved in one of the European digital innovation hubs, the one which is called Finnish AI region, which is about especially about bringing AI capacity to small and medium-sized companies. And there is an event coming up soon. You can register on the Fair Edig webpage or through this link. However, that is in Finnish. And then furthermore, something that has been coming up from this Finnish AI center that I come from is that we have this international network called ELLIS. It is a network of machine learning research sites in Europe. There are 40+ sites, and the branding is so that the most prominent ones can be labeled as ELLIS institutes. The first ELLIS institute was the coordinating unit in Tübingen in Germany, because they got lots of money from a private foundation. And now we got lots of money from the Ministry of Education, and we are now ELLIS Institute Finland, so the second one of this level. And it's the whole country. So all the universities in Finland are involved in this. It's not like just this Helsinki region. And very soon we will open up professor positions, new professor positions in all these universities. And you have the link there. I have been told if everything is okay, it is tomorrow.
Whoa.
So that is what I wanted
Fingers
to say.
crossed.
Thanks for my part.
Thanks, Patrick. All right, we have 4 presenters here today, and about 15 minutes per person. We will start from Dyn Studios. Hugo Jevert, please step on the stage. Let's see what type of story we get, kind of hearing what AI agents are, and kind of then ending up to a story where we hear some cases where they've been used. 15 minutes, so 22 past. Time is yours.
Microsoft talks about AI agents that can perform tasks on their own. Satya Nadella goes even so far that he says that they're going to get rid of apps and be replaced by AI agents. Well, Jensen Huang is basically telling us that 2025 is the age of agentic AI, and we'll have AI agents that we're managing. Sam Altman is declaring 2025, or saying that AI agents will transform the workforce this year. And of course, yes, I did these slides last week, so there was already the research. But before that, in January, OpenAI came out with the operator agent that can buy groceries. But of course, many of you know that Anthropic already had computer use that was able to order pizza. So I think that's it. So welcome to the first agentic AI of 2025. I'm sure we'll have quite many of these. My name is Hugo Jevert, and I'm the Chief AI and Data Officer at Dane Studios. That's the most agentic image I could find of myself. That's back from my banking days, chilling out on a Friday night, as we do. Dane Studios is an AI consultancy company. We're based in Helsinki, Berlin, and Munich. We have data strategists, data scientists, data engineers, BI developers, and yes, AI agents. So let's look at what is an AI agent actually. There are many different definitions. Typical things that are mentioned is independent or autonomous operations. Many people say that they are able to use tools. And one of the common ideas that is typically not really said aloud is that they're based on LLMs that can think on their own and make decisions on their own. Typically, the agents are focused on single task or at least single domain. There are experts on that domain. So then we have agentic systems, which are teams of AI agents working together towards a common goal. Any team, also these teams, they require some kind of orchestration, some kind of a leading in there. So they have different kind of workflows, and I'll talk about those in a minute also. They can, and typically have different kinds of agents in there. And some of them are not maybe these kind of what I call enhanced LLMs. And what do I mean by enhanced LLM is that here you can see a schematic of an agent which has LLM in there as the brain, you could say. It may have capabilities like tools. It may be able to call APIs or some other functions. It may be able to retrieve information from your documents or your databases. And it may have a memory where it can store information across the different sessions. So in that sense, I call this an enhanced LLM. The LLM is in there as the main thing. So yes, it has inputs and it has outputs, and it's basically communicating with us and some environment where it's doing actions. It's calling those APIs, getting some feedback from there. So if we look at some traits, I have 4 traits here for an AI agent. They probably have more also, but 4 I wanted to bring out today. So one is, of course, this communications capability, being able to talk to us in natural language, but also talk to other systems. Tool use, I also already mentioned this. So they're typically specialized into some domain. It may be math, or it may be able to search the internet for news, for instance, and so on. And then the independent operations. So as a basic thing, they're able to choose when they use a tool that they have in their disposal. So they're making decisions on what to do next. They may ask for clarifications, create larger plans. We'll look at that as an example case coming up. But like us humans, they're not operating without any boundaries. So of course there is some oversight needed and guardrails. You can have an agent that writes code. You don't want that code to be running in your production system necessarily, or you don't want to give them write access to your databases. So you'll put some guardrails around them. Then about the workflows. So I have 3 different workflows here. One is this kind of a predefined workflow, which is very good in a situation where you have a business process that you can split into tasks that you can do in a sequence. So this is kind of where we're building the programming, basically the workflow. There's kind of, you've heard about prompt chaining, for instance, and so on. So we choose how the workflow goes. But of course, we can leave that to an LLM also. So here, the orchestrator is now replaced by an LLM that makes the decision on how to go forward in the process. So which LLMs to call, which tasks to take. Each of those LLMs may be using their own tools, but this is kind of orchestrating the whole team in there. And this is better in a situation where you don't really know how it's going to go. It's still kind of the same process, but maybe the data changes so much that you need to be able to adapt to these things. And still it can contain all the same loops and so on. And lastly, we have evaluator, which is very simple and typically used in a coding situation. So one LLM writes a code, another one executes it and checks whether it is doing it correctly or not. And if it's not, obviously it goes back and it goes back and forth and back and forth. At one point, I had a very simple case of creating functions and looking at that. And after 49 times failing exactly the same way, it finally got it right on the 50th time. So it's not really very good. Okay, so how does a team with LLM as an orchestrator actually work? So let's look at the case. This is a case that we did for a multinational corporation, global corporation. They have a lot of customers, and their account team cannot keep up, cannot know everything about their customers. So we built a team that has basically a task to do background research on this customer and the market situation around their products. So we had a team with a lot of AI agents in there. First, we have Penelope Pierce. She's creating the plan and coordinating the whole system. So she's the planner in there, assigns the tasks to all of the others in the team. We have Miranda, who is doing market research, looks at the web news that we have gathered, does web research for the new information in there, and gathers this kind of information for the team to know. Then we have Charles. He has access to their internal database, can get the internal data, sales data, has financial tools to make different kind of scenarios and calculate different things from that. And then we have Leon, who's basically taking this financial information and this market information and building scenarios out from that. And of course, finally, we have Victoria doing quality and making sure that there are quality checks around in the process. But let's look at how the team works. So this takes a couple of minutes to run. We're doing a lot of stuff in there. So this is not short questions that we use here. We give them larger assignments. So here, I know it's a small thing, but it doesn't really matter from this demo what it's in there. But basically, we're giving a situation where we say, help me find arguments and justifications. I'm going into negotiations with the customer. Maybe I want to raise the price. So suggest 3 different price levels and provide some arguments for me for each of those levels. And then we can check the agent messages. This is how it starts. Penelope starts by assembling the team from the agents. So from the text, you can picked out to answer this request. We have assembled the following team. We have financial expert, blah blah blah, market researcher, and so on. And that's where it all starts. And as I said, the process is long. And now I'll just go through how it really works. So we start with Penelope doing the plan, giving out the facts, instructions for the rest of the team to do. She's also checking out what happens next. So next we'll call Charles in this case. And Charles, like I said, has the internal data, has the trusted tools for analytics, so we can trust that the results that come out from that analysis are actually correct. The numbers are correct, they're not hallucinated. We can also check the tool usage from the logs. Again, Penelope checks where are we in the plan, what do we need to do next. Next we do market research, we haven't done that. We look at the news, we look at the key drivers for our customers, the market growth potential, things like that. And also here again, the trust. So all of the stuff that comes from the internet, we have the links in the output so the user can check them that they're correct in there. And so on. So Penelope checks again, where are we next? Next is we turn it over to Leon, and he brings basically all of that information together, creates the scenarios, writes arguments that this is why we maybe could be raising the price because this and that is happening in the market here. And so now I'll go back to the trades, because there was an interesting incident at one point. So the trades here are the same as we had previously at one point. On one request from this demo data, Charles said that we don't have this data available that was requested. To retrieve this data, you should probably write an email to the financial department. And actually, it wrote the email directly for us. So just copy-paste this and ask for the data. And now, speaking about the guardrails, so of course, if Charles would have the capability to send an email and know the email recipients, maybe the recipient would get some spam from Charles asking for new data every time. So that's what I mean, that you probably don't want them to go totally wild in your systems without any guardrails. Of course, when you know that they're working correctly, you have checked, you have the human in the loop, of course you can give more powers and more tools, more capabilities in that sense. So it's not just the capabilities, it's also how much you have power to use those capabilities that I think makes an agent. Okay, then to end off with some key takeaways. AI agents are really already here. They're focused on some domain, some problems. They have special skills for that. They can adapt. So if you're analyzing a financial statement, they all look a little bit different, but they can still analyze those and adapt to the different forms that different companies are using, for instance. The development here is really fast. The LLMs are really commodity nowadays. You can take whatever LLM basically and put it in here and it will work pretty well. The workflow is really, and the tools where the development at the moment is going on. Of course, the DeepSeek, R1 and other reasoning models are actually pretty good in making those overall plans. So that's definitely a good thing happening in there. The development is not easy. So those skills, if you want to have really fast and accurate numbers from your internal data, you actually have to write those codes. Of course, at some point, the models can write the code. At the moment, like I said, it's really more a miss than a hit. But even if it gets it right, you don't always want to recreate the code and run the code again. You rather do it once, as we do in all of the other business processes also. Testing a single purpose agent is slightly difficult, but testing a team or agentic system is already quite challenging. So you can imagine that if you have some hallucinations going on in there, they may multiply when the agents are talking to each other and taking it to some other level from there. And yeah, don't forget the safety, have some humans in the loop. But finally, my final point is automating or reimagining business processes with AI agents requires actually some experience. So start experimenting and start experimenting now. And that's my talk. Thank you.
Thank you, Hugo. Really cool stuff you do at Dyn Studios. Hey, we will take questions to all the speakers at the end at the same go, so we can move on. And the next speaker we have here is Harri Valpola, System to AI.
System to AI.
To AI, and 37 is your time.
Thank you, Petri. Hello, I'm Harri, and I have been an AI and machine learning researcher for about 30 years. When I started, I thought that, okay, I want to learn how the brain works, and then I want to build one. And 30 years ago, that seemed like pretty remote possibility. But 1.5 years ago, me and my co-founder, Alexander Ilin, we founded System 2 AI to build human-like digital co-workers. So really the stuff of science fiction movies. And now it doesn't seem so remote anymore. Now the technology is suddenly there. I'm going to talk about where this AI agent business is going, or where I think it is going. I'm going to make predictions about the future, so I might turn out to be wrong. Let's see. As an example, I'm trying to use our agent. So imagine an agent which is a little bit like a human intern that you could hire. And this intern, you will need to explain the intern what you want it to do, what are the computer systems, how to use them, where it's supposed to get its instructions, and which are the Slack channels to follow, and so on. We don't have that kind of AI agent now, right? If there is one, let me know. Then we'll figure out something else to do with the company. But what I'm going to talk about is, like, why do we not yet have it? Because there are so many things that this AI agent can do at human level. But there are some things, clearly, that they can't. What's missing and how it's going to develop? So first thing that I wanted to talk about is interaction. If we have this kind of intern, then we are supposed to be able to explain the intern what we want it to do, and it will need to explain to us what kinds of questions it still has, and then maybe it starts doing its work and reports to us intermediate results and so on. So it needs to interact. Sometimes we want very human-like interaction. Sometimes it's okay to have more of a computer. So here, as an example of what interaction could look like in the future, I tested a free HeyGen system which can be used for generating some videos. So now we have a video. I hope.
Hello, I'm not a real person. I'm generated by a computer. You humans evolved to communicate with other humans. You naturally pick up on facial expressions, tone, and gestures. If we AI agents are going to work alongside you, we need to be able to do the same. Although I may still be a bit clunky, the technology is evolving rapidly. I hope we can work together in the future to build a better world for all of us.
Okay, so there may have been some issues still, a little bit uncanny valley still, but I would claim that interaction, like generating the kind of speech and even, well, some gestures. I'm not sure if I'm any better at gesturing than this version, but like there are some things to do, but this was the free version. So this is not state of the art. This is something that I was able to do in a matter of some tens of minutes. So GPT-4 creates me the script, then I go and copy paste it. Should be the agent doing that, copy paste it somewhere, and then I get this result. So interaction on the surface level isn't the bottleneck. What is? I think there are two things that I want to focus on. One of them is intelligence. They may look very intelligent, but there is something missing still. And the other one is learning. So if you have communicated with these systems, if you have tested these systems, you know that it takes a little bit of prompting oftentimes, and then you need to reprompt and try again, and it's not like a human in that respect. But it's going to change, and I'm going to try to explain why. So let's first start with intelligence. Famously, these large language models are pre-trained with vast amounts of data. So they read through all the books, all the internet, basically, and they just learn to basically imitate what's in there. They learn to repeat. They learn to predict the next word. We have, I would say, all been surprised by how far you can get with this kind of approach. it's amazing. I have to admit that I didn't believe that you could get that far. Then again, I didn't think that somebody in their right mind would be willing to spend literally billions of dollars for this thing. So they are a little bit bigger than I imagined. But you can clearly get really far with this kind of thing. But there is a point where you start realizing that imitation alone isn't really the kind of intelligence that we're looking for. There is something missing. Daniel Kahneman wrote an excellent book, Thinking Fast and Slow. I hope some of you have read it. And the ones who have read it know that there is like two modes of thinking. System one, which is like very rapid, automatic mode of thinking. And it's a little bit like just generating the next thing that comes to your mind. Spit it out. And this is what these systems have been doing for a long time. Like that's the first thing that these chat bots have been doing. But there's also another thing, System 2 mode of thinking, and that's where the name of the company obviously comes from. So we are like the company that's building System 2 based AI. And it's more like reasoning. And now you have heard about O1, the OpenAI's model, and then the Chinese DeepSeek R1, which very famously now managed to replicate a lot of that stuff and gave the model for free for all of us to use. So we can download the model, we can train the model, we can build on top of that. So yeah, something has happened. These reasoning models, I would claim, have something that you might call world models. They are able to run internal simulations. They are able to plan, at least to some extent. And this is how System 2 mode of thinking, I would claim, is also implemented in our minds. When we think and plan, we sort of go through possible futures, like step by step. What if I do this, then what will happen? And okay, then I could do this, and then that might happen. That's the kind of reasoning that enables the model to apply new knowledge in completely new ways. This is how you can get to move 37 or something like that. You can get to find new things that were not in the data. It's no longer just imitation. So if you've heard that, okay, this development is going to stop because AI agents are going to, or LLMs are going to run out of data. No, that's not the case. Like, this data is just there for learning the simple associations, but once these models start to reason, once they start to simulate the world, they will be able to compete with human intelligence in many ways. And let me just give an example about this in interaction. If you talk to a person, if it's just, spitting out answers through imitation, then you quickly get bored. Like, okay, but this person isn't really listening to me. They're just, reacting to what I say and spitting the next thing, but they're not really there. There's nobody home. But if this system has a mental model of a sort of you as a interaction partner, they understand what you think. They understand your goals. They understand your emotions. They're able to predict that, okay, now if I say that, then this is how the person will react, how I will react. They have a theory of mind, in other words. So theory of mind is one example of what this kind of system with a world model can do. So this kind of agent would be like talking to somebody who is there. Like there's somebody there inside. You will notice it when you communicate with these things. Then the big topic, I would say, learning. If you have used these chatbots, they were pre-trained, and some of them have now been trained to accomplish agentic tasks, for instance. They can They can use web browsers to browse the internet. They can research things. They have learned to do all kinds of things, but they are very limited what kinds of new skills they can learn. Typically, these agents are learning by sort of taking notes. Like if you have your profile and list all kinds of things that you like and so on, then they can add these things in your profile and then use that. They can even use so-called RAG to retrieve from memory some stuff. But it's still limiting thing to, in some sense, have to write down everything, and then when you make a decision, when you try to reason, you would sort of have to go through all your papers and try to come up with the right decision. This is how they work, and at the moment, mostly. But this is, if a person had this kind of anterograde amnesia, then they would, then there is a movie, Memento, for instance. If you've seen it, there's a person who tries to write down notes and is able to do something, at least according to the movie, but in the real world, I don't think that would work. Also, if you think of these agents, when they build up a huge list of facts, like, okay, they go to a workplace and they need to learn information about their colleagues and all the practices in this particular workplace and the project they are working on. The list keeps growing. And at some point, the agent is just completely confused and can't do anything. So they need to learn these facts. And these world models make it possible for the agents to learn individual facts. And then during runtime, when they are thinking, when they are planning, they go through these things step by step. And then they can notice, okay, actually, there's this new fact that I now need to take into account. It's very human-like. I mean, we have learned all kinds of habits. I've learned a habit, like how I go to work. I change workplace, and if I forget myself, like start thinking about something else, I'm not going to the new workplace. I go to the old workplace because it's a habit. It's just learned policy that I follow, and I'm not learning if I only follow these policies. But if I can do planning, if I can do reasoning, then I'm at the junction. Then okay, actually, yes, I have changed workplace, so now I need to go to the other route. So learning will be far more efficient and possible with these models once they have this reasoning mode, system 2 mode of thinking. So we have come to the point where we now have reasoning models, at least they are getting much better. And we are able to train them new facts. It's called fine-tuning, so it's not just compiling a list of facts, but we can actually pretty efficiently change the weights of these large language models. You can do it at home. You can download DeepSeek's distilled models, and they run in my computer, for instance, my laptop. It's not completely out of the question that anybody would do this at home. So these agents, I would say, they are going to reach human type of thinking, and yeah, it's not here yet, but if you don't bet against these AI agents. That's all I'm saying. It's a clever idea to try to prepare for a future where these kinds of agents might be there, actually. Thank you. I hope you have a lot of questions in the question sessions, but now for the next speaker.
Thank you, Harri. It's a great book, this Thinking Fast and Slow. Next speaker is a person I think we've met first time in Otaniemi campus again a few years ago. So Sirte Pihlaja and Shirute, or how do you pronounce the company name?
It's Shirute.
All right. So 15 minutes, so it will be 53 is your ending time.
Okay, let's try to head for that one. Good evening, everybody. My name is Sirte Pihlaja. I am the CEO of Shirute. We are the first customer experience design agency in Finland. Our purpose here in life or business life is to make people happy. And since I come from the happiest country on earth, Finland, that is our purpose to help people through customer experiences and better employee experiences to do just that. I'm also a very passionate customer experience professional, and I have been part of the Customer Experience Professionals Association, its founding member since 2010-11, and then running the activities since 2013 here in Finland when we started. We are active in about over more than 80 countries in the world. And I'm also passionate about artificial intelligence. I guess that's comes for sure. I'm started this podcast called the AI Experience podcast, and we are trying to find ways to give practical advice to people who are interested in learning more about how to really get AI on the go. And I guess tonight what I'm going to be talking to you about is machine customers. I have written a global best-selling book. In this book, Customer Experience 5, about these machine customers, and also we did with Elisa's Risto-Matti Partanen this study about machine customers. You can find it at machinecustomers.fi. And since I'm this crazy person, I of course have my own digital artificial intelligence twin, and please take a photo if you didn't already. It's easily found on sirte.fi as well if you don't get the chance to take that picture. So both of these are available online, so you can ask questions about CX5 and about machine customers and whatever she was talking about there last night. Today, about digital assistants, about machine customers. They are both this customer side of agentic AI. And I'm going to be telling you about how this means, what this means for businesses, how these customer encounters are evolving. To start with the definition, two Gartner researchers, Don Scheibenrief and Mark Reschino, have defined machine customers as non-human economic actors that are obtaining goods and services in exchange for payment. And I would add to that they have the intention of obtaining these goods. They might be more in the information retrieval phase, but later on I think that this is going to be an important task for them, that they actually buy things for us. And this is a $30 trillion opportunity. You can stop there for a while to count the zeros. There's 12 of them. And in the coming decade, that's the amount of business that they are going to be helping to create. Gartner bases their estimates on the fact that there are about 15 billion connected devices towards the end of this year, and in 2030 there will be 18 billion of them. I would add to that we are not, in agentic AI, we're not talking about devices, actual machines anymore, but we can have our agents run wherever in the cloud. So this is going to at least 10x, if not 100x. And as soon as next year, the estimation is that they will be running about a fifth of all the inbound customer support requests. So pretty important opportunity there. And we are talking about a new kind of business. It's B2A. We used to have B2C, B2B, everybody knows those, but now we're going to be talking about B2A, business to agents, and what that entails to us. This year, 4 out of 10 will be trying out, experimenting with these machine customers. And it's said that in 2027, about half of the population in industrialized countries will be actually using them in their everyday lives, running their business as such. And in 2030, about a fifth of the company revenue will be coming from these agents, so machine customers. So definitely you can't, it's not a business opportunity you have the possibility to miss. How will these customer encounters change when we are going from B2C and B2B to business to agents kind of business? This is a picture created by a good friend and colleague of mine, Valto Loikkanen. I think it's in its simplicity, it tells really well what we are talking about here. We are used to all having these user interfaces with traditional apps where we are in control and driving in the driving seat and taking the wheel, turning it ourselves. But we're pretty soon going to the part where our AI apps and these assistants are actually driving the car for us, and we're just looking at what's happening. And then later we will have these armies of AI agents that will actually be then taking care of all the business for us, and we will trust them to actually do so in the background. And we're talking about two different sides of the story here. So we have on the other side, we have the personal AI. Everybody is going to have their own avatars. Everybody is going to have their own avatars. So their digital assistants, their own machine customers that will be helping them out in everyday life. And the other side of the story is having talking products on the business sides, which will be agents that will then represent the products, the services that we are buying or our machine customers are buying for us. This is all about convenience. And that's exactly what you want to offer to your customers, convenience. We're also, lazy, let's be honest here, that we want, if we can have these automated systems that can actually perform tasks for us, if we just, ask them to do so, why wouldn't we? Convenience, remember that word. So this is the operator from OpenAI. What they're doing currently is exact same thing as all the big names. Anthropic launched their similar browser-based agent already in the fall. We have both Microsoft, we have other competitors working on their own systems. But basically, they're all starting with these browser-based agents. Why? Because they want to give us the possibility to be in that control and see what is happening when we're doing our, say, grocery shopping, for instance. We're letting the machine customer loose, but we're actually looking at what it's doing while it's browsing the websites. I have myself kind of a cooking assistant that creates the meal plans for me or the whole family based on the allergies, food allergies that we have, and then gives me the recipes or the different dishes, and then goes online to do the grocery, based on the grocery shopping. It would actually, if we were not living in a country like Finland, it would actually have all those groceries delivered to me as well, but that's coming soon, I'm pretty sure about that. So these browser-based agents, they still give us the control when we're doing stuff like signing in, giving out credit card details, and in different phases where they assume that we will want to take control and sort of approve what they're doing. So, but this is something that is, as I said, a learning phase, and this will pass pretty quickly. And this is definitely not a B2C thing anymore. Tactum AI is an Estonian company who's in the B2B space providing AI agents. And they have the huge deals made on their platforms already. So last year, the largest single autonomously negotiated deal that their AI agents did for one of their clients is $100 million already. And 2 million was the largest saving in a single deal that they made. And get that, 87 seconds is the time that the fastest deal was done autonomously negotiated on this platform. So you can start thinking about that these agents will make the business run quite fast, and you have to be there, you have to be fast yourselves as well. We did, like I said, this study last year where we went ahead and sort of benchmarked 40 different companies here in Finland, ranging in different industries. And we created this machine customer or digital assistant called Assi. created her as this digital assistant for an imaginary Vuononlehto family. And her personality, we tried to create all these like positive traits, so she would speak fluent Finnish and be very attractive and create these positive feelings with all the actual human agents that she was talking with, whether she'd be contacting them in the chat channel or the email channel. And so she explicitly identified herself as a digital assistant so that these representatives would know that they are talking to an AI, and this was not something that we were trying to fool them with. And she had this really pleasant personality, which meant that actually these agents, human agents working in the contact centers would have these conversations with her. And here's a few examples of the things that we realized based on these conversations. One of them is that they act so fast that, for instance, this is a health insurance case where we were buying a health insurance for a 7-year-old kid, and Assi was asking these service providers that, okay, can I get this? And they would, throw her like a 100-page document her way, hoping that they would get kind of rid of the customer. But she would actually come back in nanoseconds and then ask all of her questions from, page 57, like the second paragraph, and asking very detailed things. So if you don't have your own customer service representatives equipped with a similar system where they can go really quickly and find these things, these 87 seconds will pass quite fast. So just think about it. The other thing is also this asynchronous, difficult word there. We know all what I mean by that if your human agent takes like 10 to 15 minutes, which was the case in this encounter, whilst going to serve other customers online, it doesn't work out for the machine customer, because she'll be already asking these same questions from 50 of your competitors. So you're out of the game instantly if you're not really working with them at the same time. So very important there to go ahead and create special channels to actually serve these machine customers. We used to say that you don't exist if you're not found on Google and these search engines, but nowadays the fact will be that if you are not able to serve these machine customers properly, they will be talking with each other, by the way, as well, about the level of service that you give to them, these agents. So this is the fact of the life, that you won't exist anymore, and you will be losing more than that fifth of your business. If you want to be a future-proof organization, these are the things that you need to take into account. This will affect your business as a whole. Firstly, machine customers don't have any emotions, so you need to... the only thing that they are thinking about is the task that they have been given and the preferences that their human owner has told them, that how to behave, what to buy, and so on. So they don't buy based on whatever brand personalities you are putting there. So you have to think about in terms of marketing also that, okay, hey, machine customers, what do I even tell them? Hey, there's a parking space available in our garage. Please come our way and you'll get it on the spot. Things like that, like totally new business possibility there as well. Then also it's important to understand that you need to upskill your own personnel. It's not just about, AI literacy, it's something much more. It's about how to actually encounter these machine customers, because it will be very difficult to identify them as such if they approach you, say, through the voice channel, for instance, now that we have these different kinds of services where they sound exactly like a real person. I think Google just launched their voice agents that are actually going to call these local stores with the voice. Of course, there is an increased risk of impersonation, but this is a thing that we'll have anyhow, whether or not you're serving these machine customers. So this is something that we need to really, as a whole take into consideration, but this is IT development. It's the same thing in traditional IT development. You need to take these information security risks into account. So I hope you all got a small glimpse from this speech and an understanding of what is going to change for customer experiences. You need to really start to redesign your customer journeys from the perspective of being able to serve this new breed of customers. Thank you.
Wow, world is changing and machine customers are breeding and growing behind the corner. Hey, people on the line and here in the room, we have one more speaker, and then we are going to hear your questions. So think them, write them down. Let me scroll a few more pages so that we get there. Oh, how does this go? I'm going the wrong way now. There we go. So Petri and Petri, we've been knowing also from quite many years, so good to have you here. So Petri Ketola from Automation, and do you have till 6:10?
Okay, yeah, thank you very much. Very pleased to be over here. So as Petri told, my name is Petri, so from Automation. And Automation is about intelligent automation, and we started the company roughly 6 years ago, and at that time our vision proved to be maybe a bit challenging as to leverage AI in any type of performance improvement solutions in the companies. That was reasonably tough, and the use cases where the business cases actually worked out were very few. Today is completely different, so it changed roughly 2 years ago. Now, we'll go this way. In Finland we have roughly 25 people, then we also work in Portugal. Multiple different things and technologies, but the key ingredient is these days the AI. So without that, it's very tough to make any of these systems intelligent. The other technologies, however, are equally important, as very often the AI systems end up as proof of concepts. And in our implementations, the AI-related work usually represent only 1/3 of the entire thing. But let's go a little bit further into the agenda today. So a recap on the AI agents, how we think they are structured. It's very similar as what Hugo was indicating, maybe slight deviations there, but the basic principles are exactly the same. Then we have a case example, then how to get started, and in particular, if you are from a bigger company, as we're working with the largest companies in Finland, and of course, then there are all kinds of security-related issues and governance-related items that we need to consider. Then maybe a little bit simplified model to learning. I do like Hari's idea and approach, but we've used simple tools for that for now, and then a little bit about the governance in another case. But now, if you think of AI agents and how to get started, you need at least 2 of those components. You need the functions. Well, there's the tool that Hugo was using, or the word that Hugo was using. And then you need the planner or the orchestrator. So those 2 are the critical factors. Then, of course, you want to have the input layer, user interface. User interface could be chatbot, it could be, so this whole thing could be under the hood, so you don't even see that. But then at the end of the day, you will need some kind of a governance as in big companies. You will end up with hundreds of tools or thousands of tools. There you need to be really, really careful who has access to what, as the tools will have access to company data. And now Hugo told that it's a read-only. We are actually also writing to production systems. So we need to be extremely careful which AI agent role is allowed to write into what system. So it needs to be extremely controlled at the end of the day so that no garbage end up in production systems. We'll take case number one. This is for Bravido. Bravido is a former Barona group, turning over roughly 700 million annually, consisting of 40 different companies. And when a salesperson from that company goes to meet someone, it might be a little bit tough to really remember all the possibilities that the company has to offer. So we've developed a simple tool. It's actually a very similar concept that Hugo presented. Maybe a little bit, not maybe so analytical per se, but the workflow itself is very similar. So let's take a look. It's a small text, so I'll go through a little bit how that works out. So it's called Kasvukirja AI. I'm using it every single time I'm going in front of a customer. So I'm just putting the company name there. And there is some kind of a logic defined that it starts to follow. So it's retrieving basic information from using web search, but it's also going into our internal systems. So it's always funny to test this in front of the customer, in particular if the leadership has changed. Now, I took the Huhtamäki example as we were demoing this in front of them at the same day when they had a new CEO starting. That was a couple of weeks back. And it actually did find, it pulled the right information to this. So it was very nice. So how we built this? We built the individual functions that retrieve billing data, that what has our group of companies invoiced. So you get that. Then there's a CRM connection. Then there is a function that retrieves information about the management. Initially, we built this as a true AI agent that also the orchestration was AI controlled. That was roughly a year ago. We attached OpenAI's 3.5 model there, but the reasoning was way too slow. At that point, the reasoning, what the next step should be, took roughly 30 seconds. And if you have a chat-based system, and each step, before you get anything out of each step, it takes 30 seconds for the reasoning, it's unusable. So we moved into fixed workflow. We developed the functions first. We had the fixed workflow, but now with the new language models, the reasoning has accelerated, or they are really fast now. So we have moved back into actually AI-based reasoning and orchestration. So I'll flip through some of the examples what you have over here. So there's a little bit about the industry, what are the trends in the industry, then which companies out of the group can actually have something relevant to offer to these challenges. There is also then possibility that you know the problem yourself. There's the link to the invoicing system, who has sold last time. Then I knew the problem there. I stated that I want to then talk about AI, and then it pulls up the information about the companies who are relevant for this. This is a simple example of an agent, but the key point here is identify the simple use case and the functions or the tool. So this case had roughly 20 different tools or 20 different functions. And not all of those are used every time. It's based on their interpretation of the AI or orchestrator. Then I would actually recommend that you first start with these functions. These are actually very close to what were called microservices in the past, or they are still called microservices, but the microservices actually have the AI element, the reasoning inside each of those. Then build a static workflow so that you can actually test this. And then once it's working, the static workflow that you have defined, that go to use this function first, and then this second, and then this third, or then have some kind of a branching logic there. Then embed the AI-based planner or orchestrator and start to test that out. Then the fourth piece is the learning thing. So this is a very nice way to monitor what's actually happening under the hood, and which workflows work nicely and which workflows don't really work nicely. You can use process mining tools to look into what was the actual outcome, what was the actual workflow there, and then you can start to tune either the function specifications. As for the functions, you define the input, output, and the specifications for that. That specification for each tool or function is the thing that the orchestrator is using to determine, do I use this tool or that tool or the third one? So we have used the process mining to identify the flaws and then just simply fine-tune the function specification or the tool specifications. That's how we've been able to fine-tune the functions quite nicely. And then the governance architecture, that's really super important, that only agents with certain role have access, for example, to certain customer data. So that needs to be there somehow. Governance, a little bit also technology, what we've used basic cloud infrastructure tools from Azure. There's a tool called API management. That's a security layer. We put all the functions behind that. And then we have a plugin that pulls the function descriptions from there for the orchestrator so that the orchestrator can determine what's happening. Also then it's important to have a very traditional software lifecycle management for each of those individual tools, so that if you want to replace it with a new version, there's an automatic deployment to production there. And about the learning, this is what we've been using as. Then the case number 2, IT support, a global company. They want to reduce number of local IT support persons. They have different roles for the users. They have the basic user, they have the advanced user, and also IT support users. So we have developed few functions there. tools. One is that when people write their query, the tool first extracts the keywords of that. Then there is the integration into ServiceNow, which is the support tool, which has all the knowledge articles possible. And those are, the relevant knowledge articles are based on the geography, the user knowledge level. So the knowledge article for IT support is very different in comparison to the basic user. So that one function is just a basic integration towards ServiceNow, and we push the extracted keywords. Then the next step there is, once we get the responses, then we have an evaluation that we compare the original query and ask AI that, do these documents actually match with the query? If they do, then we pull a summary out of that. And then we also have a tool that if the person doesn't get a proper answer, then we can create an incident or service request. So we are actually writing into the production systems, and someone is going to respond to those. So sample workflow. Laser printer toner is out. End user entering issue into chat. The agent identifies the person, goes into actual personal directory, role, geography, all that is automatic. Agent extracts keywords, does the search against the IT service management system, interprets the response whether those articles actually match, then it does the summary, asks, does this resolve the issue? It's actually doing 2 or 3 iterations before it's going into the ticket creation, so there is a retrial. But if the employee is still not happy, then there's a service request entered into the system, and the centralized support contacts the employee. So quite simple use case per se, but a good example of few functions, different roles, and the answers are based on people's roles, and also you get the real-life answers, or not just the links to the documents or extracts from the documents, but fully generated answers from those source documents. Just a small example of different tools, functions. Don't need to go through these, but you can see in the presentation later on. Nevertheless, you'll end up, or any bigger company will end up with hundreds, maybe thousands of tools, and those need to be controlled and managed somehow, so that's very important. But the key thing that someone or most of the presenters already told earlier, start experimenting with these. It's not very complex, actually. Thanks.
Thank you. Can we have, don't go anywhere, can we have all the speakers on the stage, please?
Yeah.
So time for questions, and let me take a couple of questions from people on the line, and then we'll take a few questions from this room. So let's take a technical question. Let's see who of you is the best to answer this. How possible it is to deploy a large language model like DeepSeek for building AI agent on devices with limited computational power? And what are the key limitations? Techie question, who wants to try?
You already mentioned this.
Yeah, I have tried it at home. The large version of DeepSeek R1 is pretty large, but these models can be I mean, it's called distillation. So a big, large model can train a small model to do essentially the same things. And these small models are really efficient. So yeah, I can run it on my own laptop. I didn't bring it here so that you could see it, but
for Mac users, at least you can go on LM Studio. You can download easily the distilled models of R1 in there. I'm running the 14 billion model on my laptop. Fairly small compared to the original one.
Yeah, but they're still pretty good, even if they're distilled.
Yeah, we've done the DeepSeek local implementation or installation as well. We were using one of the larger models, and it was a mini PC, so the computing power itself is not very large, but the memory requirement is somewhat substantial. So we have 40 gigabyte memory there. But it's nothing extraordinary per se these days.
Yeah, if you go to the actual restriction, it's the memory. That's the biggest flaw I think NVIDIA has now. The great GPUs for gamers, but not enough memory for us.
Yes.
There. And Macs have a unified memory, so that's why Macs are pretty nice at the moment.
All right, thanks. Let's take another question from online, and this goes to all of you, and start from Petri and then go in a row. For all speakers, what agents do you use in your working life? Everybody talks about this, but are you actually building and using them on a personal or organizational level? So, are you walking and talking?
Yes, the one that I introduced, I'm using every day.
Right. Sirte?
I have about 30 or 40 digital assistants that I have created myself as custom GPTs, other technologies, and I am using them in every single day of my life. Then I have this. I'm trying out these different kinds of AI apps where you have digital assistants as well. So I really try to, experiment with all the different technologies, because we're technology and agnostic. We don't want to say that, okay, this or that technology is the best one to go with, but rather try to see what's out there. I know that currently only on one service there's a list of 800 plus AI agents based services that you can try out. So definitely there are chances.
Okay, so your digital twin sister is in sirte.fi.
Yes.
And you can ask more questions on that. Harri, what do you use?
Well, we use many things for one. There are many agents for different purposes now. Our core business is developing these agents, and the agents that we have been developing sort of help in this development process. So they are generating new data for themselves and helping in their own development. It's not might sound weird and scary even, but it's not really all that different from what humans do anyways, because when we learn, we are very active in learning. Like if you're a teacher, you know that you have to actually coach the children to learn themselves, and that's what we do. So we are coaches for these agents.
Yeah, if I may add to that, I think that it's very important that you actually treat these agents as your co-workers. So for instance, with Assi, our digital assistant who we did the study with, we would actually ask her opinions on what her machine customer experiences were, and we gave her these criteria against which to score the different service providers.
So 3 out of 4, yes. Let's see what's number 4 saying here.
I'm using all kinds of things. I can't name one. I used to do custom GPTs when that came out, then a cloud project and stuff around that. But now I guess mostly I'm writing my own stuff on top of the APIs, different kind of APIs. But I'm still going back and forth with Claude and ChatGPT or these consoles.
Yeah, we take you like a hardcore guy, so with the guitar and all that.
Yep.
All right, where's the microphone? There, behind. So a question or two from the room here. Who wants to start? Come on. There, please. State your name and use the mic, please.
Hi, I'm Krista Jante. I'm curious to know, how do you make your agent better? How do you teach them to become better?
I think this could go to all of them, and let's start from Hugo this time, coming this way.
I didn't talk about much that I left that for Harry to talk about the learning, but I'll mention now here. So 99.9% of the agents are using LLM there, and their GPTs pre-trained models. So you don't train them actually. In that sense, it doesn't work, it doesn't learn unless we write the code to do the fine-tuning in there. So, but that's slightly different. That's a bigger task to go into. So in everyday time, it's tests. It's writing tests for the agents and seeing whether not just trying it out, but actually programming tests with inputs and expected outputs and seeing if that works. And if not, then actually we need to go back to the prompting, which is kind of like programming a 10-year-old and trying to get it to do what you want it to do. It mostly does it, sometimes it doesn't do it, and it's so frustrating. But fine-tuning is different, and I'll give it to you.
Yeah, there are many things you can do. Fine-tuning means changing the weights of the LLM in such a way that it learns new facts, learns new skills, new behaviors. We actually have a new paper coming out. Minttu is the first author there. So, yeah. So the way it works, this is something that I can talk about because it's already, in review. That the agent is given kind of, I think you could call them lectures, and like guidance how it needs to handle certain tasks, and then you ask it to start doing these things, and then you collect data. Well, the agent collects data about how it's working, and it's learning to. It's like doing exercises, like you have some lecture material or book that you need to read and sort of internalize, and then the agent is trying these things out and learning how to apply this knowledge so that then it knows it without needing to read all this lecture material again. So in this way, the agent is sort of training to some extent itself by doing these exercises. I'm not sure if I'm explaining it the right way, but the same way as you would train a child in a school, largely.
Well, maybe a little bit like you would train your trainees, in a sense that if I'm, for instance, creating on I don't know, Cassidy or Relevance AI, these multi-agent networks, I will have specialized agents on the bottom ranks, let's say, that only know how to, I don't know, create social media posts or write emails or do whatever. They have just one reason for being in this life. And then there's another layer of managerial agents that then evaluate that before they actually pass on this information. So a little bit what you were explaining then in the beginning, but then that's a continuous flow that they will not go further if not accepted. And then there's of course that my own orchestrator then that will then I will have these discussions with to tell them out loud. But on my digital twin side, this is much easier because I just give them the material that I want to. For instance, the CX5 book manuscript, some of my presentations, keynotes that I have, they have been transliterated or transcribed into this knowledge base of my digital twin and the study as well. So whenever I see questions coming in, because that's the great part about these AI twins is that I know instantly if somebody asks a question that I don't have the material for. So in that case, I can just go ahead and add that material, and next time somebody asks these questions, she will know, as I do.
Hey, sorry, does a digital twin keep a record of questions that it receives that you every now and then go and look at?
Yeah, she does, and actually she sends that as an automated email for me every single day, so I know instantly if somebody is asking something.
There will be a peak of questions very shortly.
I hope so. Siirte.fi.
Yeah, so besides the approach that I introduced there, so a simple method that we are using a lot is that we ask the AI, why did you do this type of decision? So it actually usually describes the logic really well. And once you see the decision-making logic in front of you, it is actually easy to fine-tune and change, for example, the prompt within a tool So that's a way to get yourself and the AI in the same bandwidth when you start to understand what type of logic, how does that particular model make decisions.
Yeah, I take one more question from the line. We have promised to close this, but there's somebody who's jumping on their chair, so let's take one more from the room, please.
Hi, my name is Jalmari, and I have a question about the user interface side, because I think you're talking all about the back end and how everything is working, but Harri showed a little bit about the avatar. What do you other guys think? I think the future is going to be holograms and this kind of stuff, but before we get there, how do you think the user interface is going to be avatars, or what kind of way it's going to go in the near future?
Thanks, Jalmari, for the question. Who wishes to answer?
Well, I can go. So as I showed in my presentation, maybe the way to go now is the browser-based agents. And since we are not trusting these agents enough yet, we are there to approve all of the phases that require identification, require some kind of credit cards and so on. And that's the current state, but I think that that's a totally wrong way of approaching things, because you don't want to have a computer talk to another computer, through a user interface that is actually created for us humans to be able to talk to these computers. It's a huge loss of energy consumption and all of that, so it doesn't make any sense. And not to speak of the fact that they can do it much faster if they're talking machine talk.
But funnily enough, that may exactly happen if you have a corporate chatbot that can access your data, and I have my chatbot, but I can't obviously access your data. Maybe my chatbot talks to your chatbot in English and asks for that data.
Yep.
It could use SQL, but now it's using English.
Okay, I'll take one more question from the line here, and then we start the networking part. So the line question comes from Andreas. I'm taking his shortest question. What do you consider the most exciting vertical agent solutions right now? I keep hearing a lot of buzz about voice agents. What's your take?
I'll do a quick take. While back in the bank, there was a lot of discussion about voice interfaces coming, Alexas and so forth. And I'm pretty sure nobody here wants to talk in a bus about your finances with your voice agent. Not going to happen. So some things are not going to go to voice, I think.
I wonder, will there be a metaverse where I can put my digital twin there, and at the end of the working day, I'll give my digital Petri copy a task, and actually I say that, okay, make 10 of yourselves and talk to all these people in this metaverse or avatars, and then in the morning I come back and I get the best answer from that group of night shift work done in the virtual reality. Maybe. Hey, big thanks to all the speakers. AI Monday events are taking place in multiple European cities thanks to Dyn Studios. And Patrick, thanks to you, we got this room. So FKI is sponsoring the space here and the broadcasting. So to see what happens next on AI Monday front is to visit the website. Very small font there, so ai-monday.de, so it's on the German side of the world. But a lot of events coming up there and a lot of recordings there. So I think we are ready to close the call today. Thanks people on the line, thanks people in the room, but we are not escaping anywhere, so let's start the networking. Thanks, till next time.